Welcome to lesson 3.7. This is the last lesson of the chapter. So as soon as we're done this, we'll start reviewing to prepare for the chapter 3 test. The concept we're going to be discussing here is odd, even and odd functions. All right. In this example, we're going to be identifying an even and odd function from the graph. There's also an algebraic way that you can figure that out. So hopefully you were able to review the part of the notes about the even and odd functions. So if you're just watching the video, actually click into Savvis because there's a thing that you want to just look over before you start engaging in this example and the next example. So yeah, like if you actually, I can show you the part where it says concept, odd, and even functions. So I did assign that in the in what I assigned into from Savvis to like link into Google Classroom. So again, click into that if you haven't done that yet. You can just pause the video and then come back. It'll only take you a couple minutes to look at that. But you do want to look at that first so that you understand what I'm referencing here. If you are going to solve this by graphing, it is, well, let's see the solution here. It is even if it reflects across the y-axis. So they have a thing set up here where you can just reflect it over. So if it reflects over the y-axis and it's the same, then it's considered an even function. It's not what you're seeing here, so it's not an even function. If you can rotate it 180 degrees and it ends up being the same function, which in this case it does, that means it's odd. So for this example, the function is considered odd. This, I know in Savvis, it's showing that, a test for if a function is odd or not is rotating 180 degrees about the origin. I've also seen it where you just have a diagonal line, y equals x. If it reflects over that, it's kind of hard to think about reflecting over a diagonal. So that's why I believe this text is showing you that way. So anyway, that means that it is odd. If neither of those work, then it would neither be odd or even. Yeah, and then you have test points to confirm from 1, 1 to -1, -1, right? And since both are on the graph, then you're good. But again, this function is considered odd. So let's look at the next one. So same deal. You got a function there. If it reflects over the y-axis, then it's considered even, okay? It can't be even and odd at the same time. So doing that test is obviously going to show that it doesn't work. But anyway, this is considered an even function. And you can look at the definition here. And again, you got test points. You got 1, 2, and then -1, 2 are both on the graph. Those test points make more sense if you think about this in the context of it being, trying to figure out odd or even algebraically. One thing to consider, and remember, we're going to look at this in example 2, is that a function is odd algebraically if you can substitute -x in, and what you get is the opposite of the entire original function. A function is considered even if you substitute -x into the function or evaluate the function for -x, and what you get is exactly what you started with. If you get anything other than the exact opposite or exactly the same as what you started with, then it's neither even or odd. And that's essentially what's happening with the test points. This one's even because when you substitute -1 into the function, you get the same thing as you got when you substituted 1 into the function, okay? In the previous example, when you substituted -1 in, you got the opposite of what you got when you substituted 1 in. So that's how that's showing up. All right, third example. If you, hold on. All right, there we go. It's working better. Reflect over the y-axis, not the same thing. So it's not even. I'm sorry, not odd. No, I'm sorry, not even. And if you rotate over 180 degrees, not the same thing, so it's not odd. So it's not even or odd, so then this one would be neither. Again, look at the solution here. That's what it is confirming. And neither of your, so if you picked 1, 2 as your test point, neither -1, 2 or -1, -2 are on the function. So also confirming that it's neither even nor odd. All right, a you try it question. So pause it. I would just use use the graph there. Pause it, use the sliders. So I meant by use the graph. Use the sliders and see what you come up with. All right, turns out when you reflected it over the y-axis, didn't line up. When you rotated 180 degrees, it did. So that means, actually, I wrote the wrong answer. Ignore that. That means it's an odd function because the second slider worked. Rotating 180 degrees worked. So this one is odd. All right, let's take a look at the last part. Again, just you try it again. So same deal. Use the slider, pause it, use the sliders, see if you can figure out which one it is, if either. And this one, when I reflected it over the y-axis, it did line up, so that means it is an even function and also not odd. So that's it. That's how you look at it graphically. In the next example, we're going to look at how to determine the same thing, whether a function is even or odd, but doing it algebraically. All right, so let's take a look at example 2.